Alright, boys. Just wanted to show you. Just wanted to show you something I thought of here. So I had this charger for my DeWalt drill batteries. This is a knockoff brand, and it stopped working. It was my spare charger. So I bought a replacement for $17. But I was always thinking, like, the batteries snap into there, and if you could like extract that somehow, you would then be able to have an adapter that adapts to the battery, because obviously it attaches to the battery. And once you do that, you can send cords off the adapter, and then you could twist those cords around any power tool. If you could somehow get the male pins of the power tool. Wait, no, the female. Yes, power tools all have female pins that the battery normally snaps into. So you'd have to probably spot weld or solder wire coming off those female pins, or just create male spade tabs and plug those into the female pins, and then glue that onto the base of the tool. In other words, let me show you what I'm talking about here. So like with this tool, this is a little chainsaw. I soldered on a wire to each side, and then I just put a ton of hot glue, and then I just ran like two electric cords from a house, from like an extension cord. You can see. So like the live and neutral of a normal extension cord, the cheap household ones, I kept in the container, and I used them both as the copper for one of the two sides of this. So I use an entire extension cord for the left and an entire extension cord for the right. That way you're doubling up on total amount of copper that's in this, so it makes it a nice thick cord. Then I just electrical taped it real good, and then on the other end, you can see I made an adapter that will actually plug into. I made this out of like prototyping board and hot glue. And copper tape. I don't know, having struggle getting it to focus. So you can see there's copper tape there, and there's copper tape there, and it's soldered in the back to where the wire juts out from earlier. So there's a solder joint back in there. So we basically created a four-walled enclosure, and then we only touch the outside pins of the battery male pins that come out. So it just it actually fits into there. And I can show you guys that. So here it is. I can actually fit this in. Okay, now let's see if it works. See? Now that works. So this little setup does work, but making this was kind of a tedious, tricky thing to do, a little bit hard. And I was just thinking like, hey, we could get a lot more proper of an adapter, same concept, with the use of this thing that came on the circuit board inside the charger to these batteries. So these batteries actually plug into these little spring clips. You can see they just slide right in there. It just snaps right down. And now what we want to do, we want to cut this out a little bit smaller, and then we can solder or spot weld on actual wire to here, the positive and negative terminals, and then run it to any device we want to have 18 volts with I don't know, like 20 amps or whatever this thing will put out, maybe 50 amps. Might put out, actually this might actually put out 75 amps at 18 volts. So it's better than like my lab power supply at providing like high amp output. And so this could be used for like a spot welder, or it could be used for possibly even a plasma cutter. I think it would be able to produce enough burst to actually melt through significant metal, but the battery would get hot pretty quickly, so you'd have like a bunch of these, and you'd keep swapping the cord over to a different one to keep plasma cutting, so you could probably only run this for like a couple seconds. But you'd be able to actually make a cut and then just switch to another battery as this battery cools, etc. So this could actually put in some real work in terms of plasma cutting with just little batteries and a little handmade plasma cutter. I feel like that could be pretty cool. Or spot welding. You could make really good spot welding setup off these batteries, and attaching to it like this I think is a good way to do it. I would probably actually, you can even spot weld nickel strips to the outsides of these pins, there and there, as opposed to trying to spot weld to like in between the pins on the circuit board bottom half. So either way, but you can cut away everything except these pins. So I'm going to cut like around I'm going to cut like a tight square around these, and then I'll spot weld nickel strips onto these two, and then from that I'll have stubbed out that spot weld. And here's the nickel strip I'm talking about. It's 0.1 millimeter, and it's about like 1 centimeter width, 0.1 millimeter thickness. So we would like spot weld these coming off or downward off the board, like in this angle, off the sides, 1, 2, and then just those would be sticking out, and then we would be able to solder onto that a real thick solder bead of like extension cord, like household extension cord, like a whole cord dedicated to each one, or maybe even 2 cords to each one. If you wanted to make like spot welding or something, you'd want a very thick wire so the wire won't overheat, and it'll have less resistance that way for spot welding type application. But basically this will adapt it to any power tool you want, just like I did to this thing. Because I didn't want to buy the, for just a cheap chainsaw like this, I didn't want to buy its own battery and charger, which is like an extra $60 or something, when I could just use my DeWalt drill batteries, adapting it to this, which is what I did. And this is something I don't use very often. So there's no point to keep some batteries, which will probably be dead by the time you want to use it years later. Um, and I want to try to use these batteries, which I have like 5 of, for 2 DeWalt drills that are both the same type of drill. I want to use these batteries for like a lot of different projects. I don't want to have to buy like different batteries for everything. And also, I can adapt this battery to use on like my handheld vacuum too. So I just pop this in and then take it off the handheld vacuum and put it into the charger. So I could have a handheld vacuum huge upgrade by this. When those things start to die, their batteries don't last forever, so eventually I can use these. So that way we have like the same battery system and same chargers for all of my devices, and it's just plug and play, and we get to reuse these and charge them quickly. Always have a couple on the charger, always have a couple in the devices. I could have like 5 or 6 of these and use it for anything that involves portability. These are just perfect for that, in my opinion. So that's the plan. I guess I could show you guys me executing some work rather than just talking about it. So I was just able to cut through like circuit ICs and everything with these tin snips. It's pretty cool. It cuts through everything. Oh, come on. Alright, so that's really what we were after this whole time for that whole board. This is the magic piece right here. It's just a female uh, spring tensioned clasp that will go right onto our battery. No problem. And that's now 18 volts that we can tap into. I don't even think we need this part. The extra pin has something to do with charging, I think. So I might take that off. Because this is not for a charger anymore, it's for just for power. So look, now we got it down to just the 2. And this will be a really great connector now. Let me just trim off the sides a little bit more. Okay, so there we have it. A female thingamabob. And it doesn't matter which way, because I think power tools, like, the polarity might not matter, although maybe it does. Not sure. It hasn't mattered for this, I don't think. Not actually sure. Okay, so the next step will be to, like I said, spot weld. I'm thinking we could actually spot weld, well, let's see. I might spot weld. Okay, so first I'll scrape off some of the conformal coating between these 2 tabs to expose the trays, And then I think I'll spot weld directly to the trace some of this nickel tab or nickel strip. And I'll do that on both sides, spot welding it real good on both sides. So we'll then have two of these strips coming up. And I can then spot weld like a second one and a third one and a fourth one to like beef up the attachment. Because this is only 0.1 millimeter, we can basically layer it. So we'd be able to get it to like 0.4 millimeter if we put four of them, just spot welding each layer to itself, like sandwiching them. And then after that, we can even use one of these oh, I know what it's called. It's called a crimp butt connector. So it's basically just a cylinder, a copper cylinder, and we would just slide that onto these strips, which we could like bend with pliers to like make it a little more rounded. After it's stacked like 4 thick, you could just squeeze it to kind of round it and get it the right diameter, and just shove it into the butt connector, and then just pinch that down with the tip of this type of tool. You just pinch it down real good like that, and then that will create a crease in it. And we do that on both sides so that we'd go from nickel strip to our copper wire that way. But I trust spot welding onto this more than trying to solder to it. But you could solder to it as well. I'm just starting to become a non-fan of soldering. I'm just like big on spot welding now. And I actually have a spot welder, but I don't have a battery for it right now, so I actually bought 2 more spot welders that each come with battery included. And they look fantastic. I'm so excited to use them. And I could show you guys those that I ordered. I got 2 because I'm planning to start spot welding everything soon. Okay, so I just want to have more options. So I got this one. It's a single-handed look. You just with just one hand you can hold on to it, and the batteries are built into it. It's like a welding pen. How convenient is that? But then for certain type of stuff, I think this will be better because it's got 2 separate leads, and you can like get it into different angles, different tight spaces to try to do that type of weld. And these are pretty reasonable. I think this one's 50, their one's 30. I know that I'm going to use it so much that it was a good investment for me. Even though it's kind of a little bit expensive, but it's not that bad, because like if you buy the little welding kit, I even bought like the $12 spot welder, and it's a kit and you have to assemble it yourself. You have to like do some soldering to put it together. The problem with that is it comes with no battery, so you're spending $12, but then you still have to assemble it, and then you still have to buy a battery, like a LiPo battery, which was like another 30. Then I had to buy a battery connector, which was another 8. So like I'm like 40 more plus the 12. That's like $52. And these are like $48, include the battery, include everything. It's ready to go out of the box. And it's got an LCD and everything. It's way better design. It looks good. It's just way better design than those little cheap Chinese knockoff like build it yourself kits. Now the build it yourself kits can be good if you just have a very low budget. You want to spend $12 or $8 and then you're willing to uninstall your car battery and connect it up to your car battery as the battery input. And that's actually what I did the other day to test it, to test my welder, as I waited for a LiPo battery to come in by mail. Um, or you could buy a couple 18650s for like $5 each. That's $10. Or no, it'd probably be like $6 each for like a really good one. You could try to make your own battery pack to run your welder, but then you need the welder to make the battery pack, kind of. So it's kind of a catch-22 there. Um, but at the end of the day, I recommend just buying one of these. They're pretty awesome. One's 40 and one's 48. I just had to have them both. I've been saving up money for like robotics and stuff, and so I used money I had set aside for some years now that had been building up to buy motors and tools to build a robot. So I had that on hand. So anyways, that's the little project I've been doing, and I hope you guys enjoy that. I think it's going to make a cool little adapter. You guys got to see the other adapter I made. This is just another way to make an adapter using a charger.